Here we are with the true-false. And so let's go ahead and answer them. Power represents the probability that we correctly reject a true null hypothesis. Well, we can't correctly reject a true null hypothesis because if the null hypothesis is true, we shouldn't reject it. Power is the ability to correctly reject the false null hypothesis. If the null hypothesis is false, we should correctly reject it. If we fail to reject it, we've made a type 2 error, which is beta, and 1 minus beta is the power because power is not making a type 2 error. This first true-false is false. If based on the same data set, you changed your level of confidence from 90 to 95, the resulting 95% confidence interval is considered less precise than the 90% confidence interval. So our 95% confidence interval would be less precise. It would be more confident, but less precise. So if you think about precise, it would be like your friend telling you, I'll show up between 2:55 and 3 o'clock. 2:55 to 3 o'clock, you're like, okay, they're going to be here very small interval. What if they said I'll be to your place between 2 and 3? That's not very precise. And that's the same thing that's going on with our confidence interval. It's getting wider when you go from 90 to 95, so it's less precise. This is true that we became less precise when we made a wider confidence interval. A p-value represents the probability of seeing the results you saw, results more unusual than that, assuming the null hypothesis is true. And this is a good definition right here, because the p-value is the probability of our results, or results more extreme, happening by random chance variation, given that the null is true. The only way to decrease the probability of a type 2 error is to increase the probability of a type 1 error. That is one way. That would be increasing alpha. If we increase alpha, we lower the probability of a type 2 error, but we increase a type 1. Imagine using an alpha of 1. You would reject everything and make tons of type 1 errors. This is an alpha of 1, which you would never do. You would in turn reject everything and never make a type 2 error, because to make a type 2 error, you have to fail to reject the null when you should. And so you can see the larger your alpha, the less type 2 you make. But another way, and the reason this is false, is to increase your sample size. When you increase your sample size, you become more certain. So the more certain you are, the less you will make a type 2 error. The other thing that affects the type 2 error is the effect size, and that's something we can't change. That is the true difference between the null and the truth. So I often say, if I were to play my brother in basketball, the null would be that we're the same. And it might be hard to see because although my brother is better than me, he's not a ton better than me. But what if I were to play Michael Jordan in basketball? Well, the null would be that we're the same. And then the alternative would be that we're different. But in this instance, the effect size, the true difference between the null and the truth, is much larger because he's way better than me. So you're going to see that easier. It's a much more powerful test. You're going to reject the null much better when I play someone way better than me than when I play someone closer to me in skill. And that's what effect size is. But you can't control effect size. It's just the true difference between the null and the truth. In the business analytics presentation class, we discussed how Target uses data to try to determine if a loyal customer is about to stop shopping there. And I'm sure they do stuff like that. But that was not our example. We talked about the girl whose parents found out she was pregnant. It's quite a good story, and I suggest going to watch the video to check it out. Quite a funny story. And that does it all for the tests. If you have questions, feel free to email me, and good luck.